Hi, this is Dave Edstrom. I am the CEO and CTO for Virtual Photons Electrons. Prior to this, I was the CTO for Memex, and then prior to that, I was the president chairman of the board of the MTConnect Institute. And way back when, I was at Sun Microsystems for about 2.5 decades. Today, I'm going to talk to you about the implementation guide for machine tools, devices, and sensors. And what this will cover is for those companies that are thinking about implementing MTConnect, and I'll get into some of the details today. Specifically, going to cover what is MTConnect, talk about the 3 A's of MTConnect, which are the application, the agent, adapter, how to differentiate with the standard, latency from the device to the application, connecting machine tools, devices, and sensors. And then I'm going to go through and talk about where you can get additional resources such as source code, where there's some labs, tools, simulators, examples, and documentation. And then we'll wrap things up. So first, what is MTConnect? Well, it's an open and royalty-free standard, and it speaks proven internet standards such as HTTP and XML, and I'll get into more details on that. Importantly, MTConnect, it's free to join and free to deploy. It's open source. The way to think about MTConnect, it is the Bluetooth or USB for manufacturing equipment and applications. From a high level, MTConnect has turned a piece of manufacturing equipment, such as a machine tool, sensor, what have you, into a secure and small website. It's extremely easy for software to speak to MTConnect-enabled equipment because all modern software today speaks HTTP and XML. It has become the international interconnectivity standard for manufacturing, specifically discrete manufacturing. The mantra that we like to say about MTConnect is different devices, common connection. So who is MTConnect? Well, it was started by AMT, the Association for Manufacturing Technology. They are the ones that have really put in a tremendous amount of resources, a tremendous amount of dollars, time, and it's through AMT's leadership that MTConnect came about and continues to exist today, along with its many members. And speaking of members, for those that are outside the manufacturing community and are just seeing MTConnect for maybe the first time, just thought I'd share a few names that I think most folks would be familiar with. Boeing, Bosch Rexroth, Fanuc, Foxconn, those are the people that make the Apple products. GE Aviation, General Dynamics, Lockheed Martin Electronic Systems, Mitsubishi Electronic Aviation, Palo Alto Research Center, also known as PARC, and there's many, many more, and you can go to mtconnect.org to see a complete listing. So before MTConnect, how did things look? Well, it was the classic n-squared problem. Over on your right, you have 5 different applications from 5 different companies. On your left, you have 5 different machine tools, all speaking different languages, different vendors. And the language I'm referring to is the language that you would speak to these systems in order to get information from them, such as what are they doing. Here you see the rat's nest that happens when each of these separate companies on the right, such as App A or App B, when they have to speak to these different machine tools. Each of these companies have to create their own device driver to speak to the company, because if I am the owner of the company for App A, I'm certainly not going to give that software to App B. And so each of these people have to, or each of these companies have to reinvent the wheel, and you see this n-squared rat's nest that happens quite quickly. So let's look at how MTConnect changed things, and we like to say that MTConnect is elegant in its simplicity. We have the same 5 machine tool companies, and we have 5 applications. What we've done is we have moved the problem of translation to where it belongs, which is over on the left-hand side near the machine tool or the sensor. And so what happens is that these devices, in addition to speaking their own language, which very often was proprietary, it speaks MTConnect. And what's important is, so what has happened from the application side? Well, now each of these applications, all they have to do is speak MTConnect, and they can speak to all of these different machine tools. So that's why the way to think about this is Bluetooth for manufacturing, because when you go to buy a car or get your wireless Bluetooth speaker that you're going to use at the beach, you don't want to have to worry about proprietary ways for these devices to speak to each other. If you go to buy a brand new car and Apple came out with iTooth for the iPhone 8, and you had to have special iTooth protocol in order to use their headset or to speak to whatever, you would not be pleased. So again, the way to think about MTConnect is Bluetooth for manufacturing. Open, royalty-free, and open source. There are 3 A's to MTConnect. So I'm going to take you through here from the device all the way through the application. So a device could be anything: a machine tool, bar feeder, compressor, a sensor, you name it. And these devices can speak a variety of protocols. It could be binary. It could be something like Fanic Focus, Fanic IO Link, OPC. Could be analog, could be digital, could be Billy Bob's protocol from West Virginia, and it could literally be anything. So what happens, the first A is the adapter, and the adapter is hardware and or software, and that reads this proprietary protocol, or could be a different protocol, and it converts that to what's called shutter, which is simple hierarchical data representation. And shutter is very simple, as you see here. It is pipe delimited ASCII data where there is a timestamp at the beginning, and then you see where it will list a set of key value pairs, and below you see sort of a snapshot of this. This is not officially part of the MTConnect spec, and this is what most companies, all that I am aware of, have used for MTConnect up to this date, which is July 2017. One thing to point out is a new agent is being worked on that will have more inputs as well as more outputs. So I'm talking about the agent and the architecture and the adapter here that has been around since the beginning. So here we see the MTConnect agent. It receives shutter from the adapter, and the way to think about the agent is that it is a piece of software that sits between the adapter and the apps. So the beautiful thing about MTConnect and the agent is that it is very simple in terms of how you speak to it. You can literally speak to it from a browser since you're speaking HTTP. For example, what you see here is I could put in my browser mymachine.de-mfg.com, and I could then send commands to it to retrieve information. And the commands that I could send could be probe, tell me what physical devices you have and what data can I get from you. I can then do a current, which tells me what is currently happening with this particular device by talking to the agent. And an agent can talk to multiple adapters. An adapter can talk to multiple agents. And I can start going through and doing samples. And I can also talk to it using a command called an asset, which is formerly called a mobile asset. And that is basically devices that are not always attached to a given machine tool. As to give you one example, applications are typically shop floor applications, but it could be anything. And this is just showing Merlin as an example, which comes from Memex. Again, the common mantra for MTConnect is different devices, common connection. One of the questions that comes up when I speak with different companies is, well, how do you differentiate with a standard? Isn't this just me too? And it's a valid question. And so one of the areas to think about is the difference between a interface and an implementation. So let's separate those two out. You can differentiate by having the best implementation. Also, MTConnect is extensible. And what that means is that the secret sauce with MTConnect were the different vendors that have come together to agree on a common dictionary, also known as an XML schema definition file, .xsd. And where they agree, that becomes part of standard. Where they disagree, they are welcome to extend with their own namespace. And so that's another way to differentiate. And with the MTConnect Institute, since it is free to join and free to deploy, as long as you agree to the IP, then you can be part of the leadership in terms of creating different areas of where you feel there's a need and others feel there is a need. And here's just a few examples of areas, such as security or availability that people can get into where there's technical working groups. And the technical working groups, known as MTAGs, or more formally the MTConnect technical working groups. And as I mentioned previously, there is a new agent that's under development, and that is out at github.com, and you can go out there and track that and participate in that if you'd like to, being written in Node.js, and some of the lower levels will likely be optimized in a more traditional language such as C++ or C. You can join this working group if you like. There is a device functionality profile, and you can consider joining that group and extending this baseline. I will get into that. And specifically, in terms of the device functionality group, is you can look at what Mazak, Akuma, DMG Mori, Dusan, and Noom have already done as far as providing baseline offerings. And then, of course, you could partner with shop floor monitoring companies to break into different markets. So this just really touched on how do you differentiate with a standard. And I think the MTConnect Institute, and particularly AMT, have done an excellent job with managing this entire process. So let's just take a look at this from a developer standpoint. And let's see which is easier for developers. A proprietary protocol, so this is prior to MTConnect. So we have to figure out what all those ones and zeros really mean. And this can be a non-trivial task as a developer. So they have to spend a lot of time, could be reverse engineering what's already out there and doing it on a per machine tool basis. What's interesting about machine tools is that you can configure these many different ways. And while that was very helpful in terms of flexibility, the challenge is that you could have different machine tools coming off the line and they could be configured very differently, even the exact same machine tool. And so that didn't lend itself to ease of use in terms of getting data from these systems. So developers have to waste time figuring out what does all this data mean. And typically developers like to create value as opposed to just sort of doing this low-level bang your head against a brick wall just to get the data before you can start adding value type of work. So since MTConnect is based on XML, it is both human and machine readable. And here's just an example, a few examples, I guess, of what MTConnect will show. And here's just showing something from the asset part of the dictionary in terms of showing that what some of these IDs mean and their types. Here you see avail, which is type availability. And then below you see an example I think people can appreciate and understand, and that is the number of assets. Well, it's showing that this number is an integer, It's showing that the values can be anywhere from 0 to 4.2 billion. And what's important about this is that both computers can read this and humans can read this. So instead of trying to figure out what all these ones and zeros might mean on a proprietary protocol, here you know exactly what the name of the asset is, as well as you know, well, what are the possible values. So this is a big, big win. And this was the hard part with MTConnect, is basically getting these companies that were competing every day of the week to come together and to agree upon what will be this common dictionary of terms that we're all going to agree that we use. And this is what really differentiates itself, quite honestly, from other standards who don't take that on because of just the overall challenge to do it. Software developers, they want to write applications that give their audience, and they want the widest audience, the best value and as fast as possible. So let's dig under the covers a little bit here, and let's talk about just basic communication. So the device is sending information via the adapter, and then it goes to the agent. The agent is collecting this information, and it saves it in a circular buffer, and that buffer can be defined to different sizes. The default is 2 to the 17th, which is 131K, and the data flows through the device to the adapter to the agent, and this is all implementation dependent. Also, that the flow from the application to the device is something that the client will make the request, and then it will also store it locally, because one of the things to keep in mind is that the agent does not store any data locally. It is a memory circular buffer. So the first request is to do a probe. Basically, tell me about yourself and tell me the data items that I can get. Then the application will request the current state of the device, and it will report back on exactly what's going on in terms of the particular machine tool, sensor, bar feeder, compressor, what have you. And then after that, the application will start doing sampling, and it'll use the sequence number to know where it is when talking to the agent. And there's also an instant ID so that you know whether or not the system or the agent has been restarted. And then the results come back that are events, conditions, and samples. And the default is to provide 100 event samples or conditions when you're doing when you're querying information from the app to the agent. And this information can be set through different configuration files, which I'm not going to get into for the purpose of this particular presentation today. So there's 3 types of devices, and I think this is important for people to understand, because when we have conversations about MTConnect, typically people very quickly get to this level. And so there are terms that we have, so let's discuss what each of these means. Native, and this is the most popular with machine tool makers, where the adapter is native and sometimes the agent is as well. What this means is that MTConnect is built into the device itself, such as the machine tool. Next is called translation dependent, and translation dependent is where there is a Linux or a Windows box that's running the adapter, possibly the agent as well, and it is speaking to a machine tool or a sensor that has an API or an application programming interface, and it's speaking to it via software to retrieve information in a given protocol and then translate that eventually back into MTConnect. And that's where the name translation dependent comes from. The third, and this is really for legacy machine tools, is called connection dependent. And this is sometimes offered as a black box. And what I mean by black box is a completely separate unit that might be running Linux, typically, possibly Windows. And it has a variety of connections on it, such as analog, digital, USB, maybe where you add additional sensors, Ethernet, and other types of connections. And when you use this box, you typically have software that also needs to be configured, or also is used to talk to these various type of signals to then translate or condition that so that it eventually becomes MTConnect coming out of that box. And examples of this in the industry are Mazak SmartBox and the MTC1 from MX. One of the questions that also comes up is, well, so how accurate is MTConnect? And I think sometimes people sort of get wrapped around the axle on this. So thought I would spend just a little bit of time discussing this. This is in the MTConnect specification part 1. And the date and times follow the W3C ISO 8601 format. And that allows for arbitrary number of decimal fractions of a second. Now, there is more detail at this particular URL that you can go check out. The format typically, this is what you see here, and I think self-explanatory, years through month, dates, and hours, minutes, seconds, and fractions of a second, for example. And I think one of the key points here is that when you look at the accuracy of getting information from a device, with MTConnect, you're gathering information, but it's not something that is used typically where you need extremely low level, low latency because you're doing real-time control, and I will get into a little bit more of that a little bit later. So here we're talking about real-time, and what does real-time mean? Well, real-time is in the eye of the beholder, and I put quotes around real-time because it does mean different things to different systems. In the computer industry, what real-time means is a guaranteed response time from an event to a system response. And what the computer industry really cares about is guaranteed or predictable latency. This is not part of the MTConnect spec. And as I alluded to on the previous slide, MTConnect was not designed to take the place of a closed-loop system where guaranteed response times of nanoseconds or microseconds are a hard requirement. If that's what you're looking at doing, then you're looking at having hardware directly on a controller with a very tight closed-loop system with some type of real-time operating system and real-time application to go on top of that. The way to think about MTConnect is it's the Bluetooth for manufacturing to gather data on what different systems are doing, and it can do that at a very fast speed, but when someone starts talking to you about real-time, you really need to find out what are they referring to, because again, real-time is in the eye of the beholder. And here, this last bullet, it talks about the interval parameter that the MTConnect agent can have, and this is defined in milliseconds, and an interval of 0 indicates the agent will deliver data at its highest possible rate. Let's look at the initial business steps. Let's say I'm a machine tool company, a device company, or a sensor company. Well, first thing, create a small team to determine which 2 or 3 machine tools or devices do I want to MTConnect enable first. In other words, don't try to boil the ocean, because you'll want to learn about MTConnect and the steps you'll need to go through just with a small subset. And of course you'll need a technical developer. Of course you need a product manager, someone who knows your CNC or your device or sensor inside and out. I know that sort of goes without saying, but that becomes very important. And of course a software developer. You might need a hardware developer if you're going to develop your own box. Of course, one of the things you want to do is download the MTConnect specification at mtconnect.org. You want to check out the MTConnect device functionality group, examine what everyone else is sort of doing if you're a machine tool company. I've mentioned these companies before previously. There are a few very good documents that are out there. One is called Getting Started Shop Floor Monitoring. That's a high-level overview. Would definitely recommend checking that out. And then this, easy to say, can be very difficult to do sometimes. Determine what data can be accessed and how to access this data from your machine tools, your devices, or your sensors. And then make the scope of the data items that you're going to first make available. You don't have to provide everything, and that's one of the classic mistakes that people sometimes make, is they think that out of the chute they need to provide absolutely every data item that they can get, and that's typically not the case. So determine what's important, and you can do that by talking to what your customers want to have. Yeah, you can talk to your competition, you can look to see what they're doing. There's many ways to determine that. If you have older systems, something that you might want to consider is teaming with one of the companies that already have hardware software adapters, so you can simply offer something. It's non-trivial to create these black boxes and to really do it the right way in terms of providing all the tools that people typically want to see, and then to go through the entire hardware software development, testing, qualification process. And of course, join the MTConnect Institute. There are different tag meetings that are held typically 3 to 4 times per year. Many times it's 3 times in person, and the 4th is sometimes a remote meeting where people will join. So please join the MTConnect Institute and also sign up for these. So how long does it take to write an adapter? That's probably one of the most popular questions that we get. And the right answer is, it depends. Well, what does it depend on? Is this native? Is it translation dependent? Is it connection type? Is there a known and proven hardware connection, or do I need to engineer a hardware solution? Is there an application programming interface defined? Do I need a third-party library or a specific license? That's sometimes an issue that people overlook. And they'll get down the road and they'll go, oh crap, we need to license this. And they didn't factor that time into it, nor sometimes they didn't factor the cost that's into that. So you have to absolutely be aware of this as a possible issue. Does the device have the CPU power to handle status queries? We've seen that happen a number of times, where the control has plenty of power to make parts or to run whatever, but it doesn't have the CPU horsepower to also do status queries at the same time. So then you have to go to a third-party box, or sometimes you have to wait till the next controller comes along. What programming language is the best choice for the adapter? And then what types of adapter configuration options are required? This is something that people typically overlook, where they make some assumptions on what data needs to be given and how it needs to be configured, how you want access to it. And they go to do some alpha or beta testing, and their customers say, well, no, this is not nearly good enough. So you really want to find out about that. And then, do you have the necessary hardware configurations all in-house, or you need to work with a customer? What I mean by that is, let's say that you have your system is called the FUBAR 1900, and you have those in-house, but the customer says, oh, I want to run the 1800. I want to put MTConnect on that. And you don't have any in-house anymore because you no longer make those, but you need to do testing on it. Well, will you get access from a customer? How will you get access to the hardware to do the testing? Again, obvious points, but things just to be aware of. Does your development staff have MTConnect expertise? Or are you going to have to hire a third-party consultant? Or you have to factor in how long it's going to take for them to get up to speed on MTConnect? Again, MTConnect is elegant in its simplicity, but like any spec, you have to take the time to learn it. And then, what is my company's software development lifecycle, time frame of planning, analysis, design, development, implementation, testing, deployment, as well as maintenance look like? How does this fit into what my company currently does? The reason I mention this, again, an obvious point, but I've heard some people say, oh, I think we can have this done in a week. And I'm like, really? Have you ever done that before? No. Well, why do you think this would be different? So this is not to overstate the complexity. It's simply a reminder that when you're writing an adapter, it's like any type of hardware or software, is that there is a methodology to do this the proper way, and that's something to remember. So finally, how long does it take? Well, again, the right answer is it depends. There's a functionality group that I spoke of, and this is available at MTCup, the MTConnect user portal. And here's just showing the profile of a given machine tool and what data they provide and then what data they don't provide. The reason I'm sharing this is because there are many customers that when they read about MTConnect or they take a look at the spec, they go, oh, they must include everything that's listed here. And the answer is no. Typically that's not how it works. It goes back to the earlier point where it might be phased in, or customers haven't asked for it, or there are some things that just don't apply. For example, there is no device, there is no door here, let's say, or what have you, or they decide not to support it. So this is something that's important to check out to see what your competition is providing, so you have a rough idea basically where the bar is. The MTConnect standard is broken into 6 parts, and I'm just listing these parts here. Again, you can go out and download these specifications. This is showing the 1.3 version, 1.31 as well, depending on which part of the standard. So please download those. There is lots of information that's out at GitHub for the MTConnect Institute. And what I mean by that is there's source code that's out there. There's binaries. There's simulators to simulate a machine tool that's creating something. There are labs, lots of documentations and examples, just tons of information. And this is just showing really part of it, where I have 2 screens. The top part here is showing the new, on the left here is showing the new agent that's being worked on in JavaScript, and is showing the C++ agent, which has been out there many, many years, very stable and reliable. And then on the right here is showing just some of the example adapter code that's out there. So again, please check out GitHub. And the other thing I'd recommend is that when you're looking at doing MTConnect with the agent, you could certainly write your own agent, but if I were in your shoes, I would take advantage of the software that's already been out there and well proven and well debugged. So please check out github.com. The adapter is not part of the official spec, but all major implementations of the MTConnect today are using Shutter, simple hierarchical data representation. That's the timestamp with key value pairs to speak from the adapter to the agent. So that's something to consider. Again, there is a new agent that's being worked on that'll increase the types of protocols that can speak to the agent, so you can check that out if you like. MTConnect.org is a great site. There is a Getting Started connectivity guide that you should check out. The MTConnect specification that I just showed you. There are how-to adapter labs that are on YouTube that were done part of the MTConnect conference called MC2, and you should really check those out. They're extremely well done. Will Sobel, who is from System Insights and Chief Architect of MTConnect, has done a number of these, and they are excellent. There's the MTConnect Institute YouTube channel that you can check out. Lots of videos that are there. And I'd mentioned before, please don't reinvent the wheel. There's lots of resources that are out there for the reference agent architecture, adapters, and simulators. So please go out there, check that out. MTConnect CUP is the MTConnect user portal, and that is a great place for lots of white papers, FAQs, and questions. Since it is a forum, you can get an ID there, and you can post questions, and people are very good in terms of responding. And there's more detail that I put out on the MTConnect date and time, since many times people want to get very detailed on that. So I provided an extremely detailed look at date and time at tinyurl.com/MTConnect date and time. And then there are different MTConnect courses that are out there. I know that Neil Desrosier of Mazak teaches one. He's been teaching those for years, and those are excellent. And you can go to Mazak to check those out. And then there's a variety of partners and consultants that you can work with who can basically help you through to expedite your journey as you MTConnect enable either machine tools, sensor devices, what have you. So again, lots of people out there, and the folks that attend the tags are all very helpful. The simulator is something I think that's an excellent way to learn how MTConnect works below the covers. And this is something that I've documented here. The simulator is already out there. It's been written. And again, it runs from the device to the adapter, the agent to an application. And so it can run for either Unix systems or it can run on Windows. For this example, I've just gone through and showing you how some tools I use under Linux to basically monitor what's going on. Essentially what happens is that the simulator takes a log file and if you look at it, it's Shutter, of what a machine tool has been simulated to do, or maybe what it actually did, and then it feeds it into the simulator so it appears as if it's really happening live. And so the steps are here, and I'm not going to go through each of these. You can go through these, but essentially you start an agent up in debug mode in one window, terminal window on the Linux system, and then you start the simulator up in another window. And then in a third window, you can trace using TCP dump port 5000, which is what the application will speak to the agent on. And then you can start up your fourth terminal window with TCP dump on port 7878, and then you're monitoring what the adapter is receiving. And that just sort of shows you the low level, what's going on. And then if you start up a browser, you can start going through your MTConnect commands, such as probe, current, and sample, and then you can watch what's happening in the two trace windows to see exactly how the information is flowing through the 3A's of MTConnect, the adapter, the agent, and the application. And here's just some commands that you can execute. And here's just showing using the port and doing it locally here. So if you go through and you start doing this, it's just showing what you would see in some of the windows. For example, here it's showing what when you start up agent debug, it will do a ping and pong, basically hello, hello is what's going on there. And then there's a heartbeat just to make sure that the agent and the adapter are speaking. And then in the third window, you'll see some HTTP protocol will be displayed. And then in this fourth window, you'll see the shutter, and here you see the shutter, which you see the timestamp at the beginning, and then you see the key value pair, such as the first one. You see Y, ACT, and then the 0.6517, blah, blah. And so again, a single timestamp and then a single key value pair is what you're seeing on the lines here. And then you'll start up the browser and you'll go through and you'll see different type of requests there as well, where it's showing you what's happening from the browser perspective. So again, this is just a way to see what's happening underneath the covers. I showed you, how to do this under Linux. Obviously, you can do this under Windows and use some type of packet tracing for Windows. Sometimes people like to use Wireshark since that's free. But I found that for technical people, this really helps to understand the 3 A's at MTConnect. Again, here's some of the primary sources or resources that are out there. You see mtconnect.org. You see what's out at GitHub. You see the YouTube channel. You see the MTConnect users portal. And again, this is Dave Edstrom. I'm the CEO/CTO for Virtual Photons Electrons. I went through today the implementation guide for machine tools, devices, and sensors. I hope that you found this interesting. And I hope that you join the MTConnect revolution, because it really is the default interconnectivity standard for discrete manufacturing. And it is open source, royalty free, free to join, and free to deploy. Thank you.